Good day, everyone. Our group will be presenting our KPPB OPD for mathematics, focusing on two courses, which is Calculus and Technologies in Teaching and Learning Mathematics, under the guidance of Dr. Nor Deliliana binti Admon. Our group members are myself, Karina binti Karuzukarnain, Q Kaiki, Irene Lau Yuchin, and Muhammad Amafaris bin Muhammad Fauzi. Our presentation is divided into three phases, which is the first one, planning phase, that covers the interdisciplinary connection and CLO selection. The second one is discussion phase, which focuses on the big ideas, essential questions and assessments. And lastly, implementation phase, which is highlights how the course was applied in teaching and learning. Both courses are closely connected, which is from calculus provides the mathematical foundation involving derivatives, multivariable functions, and equations, and whereas technology in education provides the pedagogical and technological aspect showing how technology can enhance mathematics teaching. Together, they create an interdisciplinary bridge between mathematical theory and technological application. For MTS 3293, students analyze real-life mathematical problems, determine graphs of multivariable functions, and identify gradient fields. Whereas for MTS 3312, students apply computational thinking and organize digital skills in mathematical pedagogy. So our combined video project integrates these CLOs using technology tools to visualize and explain mathematical concepts. So, when both big ideas merge together, the interdisciplinary theme is tech driven minds, interactive math, see it, explore it, and solve it. So, these are the essential questions that will be answered in the following presentation. So for the courseworks, for MTS 3293, students complete a real-life project and quiz. So for MTS 3312, students do a quiz, video project, and micro teaching using technology tools. These activities encourage hands-on and technology integrated learning. Both courses emphasize higher order thinking skills, analyzing, applying technology, and demonstrating real world connections. Through this OPD project, students integrate mathematical understanding with digital competency, aligning with KPPB's goal for meaningful learning.
Greeting everyone, I am QKT. For my part, I will share how KPPB in teaching and continuous assessment support deep learning through 60 elements, which include character, citizenship, collaboration, critical thinking, creativity, and communication. These elements will help us to create learning experiences that are meaningful, ethical, and student-centered. The first element is character. So in MTES 3293 calculus, we often face challenges when learning abstract topics such as differentiation and integration. So in this course, we learn to develop patience, perseverance, and empathy not only towards others, but also in managing our own learning process. Um, it provides extra support sessions or alternative explanation from lecturer. When we struggle to understand, we support one another by discussing concepts, attending extra section, and sharing simpler visual explanations. This experience helps us build strong character, a positive attitude, and confidence in solving mathematical problems. We also show character by using digital tools like GeoGebra, Desmos, and Polypad. Responsibility and creativity to strengthen our understanding and confidence in mathematics. Next element of citizenship focuses on using technology ethically and responsibly. In these courses, we learn to use software ethically, respecting copyrights, and giving credit to online resources. We can see how technology can support inclusive and equitable education. For example, by creating visuals or materials that are accessible to all learners. This helps students develop awareness of our roles and responsibilities in the digital world. Moreover, element of collaboration plays an important role in both courses. We work in groups, discuss ideas and solve problems together, especially when we use mathematical software. For instance, students collaborate in GeoGebra to design a graph that explains a calculus concept. Through teamwork, students learn to communicate clearly, support one another, and build interdependence, which are all part of meaningful learning.
Okay, for the communication in 6C elements, student can present mathematical procedure and tools instruction in a simple and structured way. Other than that, they can practice verbal communication and explaining skills during their presentation. So, the next element is creativity. So, in this part, student can design a creative learning materials such as interactive graph, animated demonstration, or visual problem solving activities. Okay, for the last element is critical thinking. Promotes higher order thinking as students not only use the tools but also make critical decision about how it enhance mathematical understanding. Other than that, evaluate the tools features, accuracies, and suitability for classroom use.
Next, under KPPB in Teaching and Continuous Assessment, we focus on learning competency meaningful, also known as Element 3E, engagement, enhancement, and extension. For engagement, students are actively involved in the learning process through interactive and technology based activities, making lessons more dynamic and participatory. Second, enhancement. Students strengthen their understanding through visualization, simulation, and step by step exploration. For example, using digital tools like GeoGebra to visualize multivariable functions. Lastly, extension. Students apply both mathematical and technological knowledge to authentic real life projects connecting theory with practice. Through these three elements, learning becomes more meaningful, interactive, and relevant to students' real world experiences. Under the KPPB framework, we also apply the 3R elements, which is reputation, retail, and relationship. In this project, the focus is on relationship where teamwork and collaboration play a key role. Working in a group encourage communication, sharing of ideas, and creativity. Each member contributed their strengths. Some explored digital tools, some prepared examples, and others designed materials, helping us build mutual respect and strong cooperation.
Next, we continue with the impact on students and lecturers. So, for impact on students, it can build strong connections between students, lecturers, and the learning community through collaborative projects, and to enhance student engagement and participation through interactive and technology integrated learning methods. And however, for impact on lecturers, which are encourage diversified teaching approaches using various digital and interdisciplinary mediums. And the lastly is inspires lecturers to cultivate innovative and critical thinking among students, motivating them to think beyond conventional boundaries. So, for conclusion, nurtures future educators who are knowledgeable, creative, and reflective in integrating technology with mathematics. And it also can develop innovation and collaboration skills essential for 21st century teaching, and to produce future ready teachers who can design meaningful technology driven learning experience and continuously improve through reflective practice. This is the link OPD for course MTS 3293 and MTS 3312. And that's all from us. Thank you for listening.